Hello, everyone, and welcome to our final presentation of the day. Just a couple of housekeeping items before I introduce Gareth. Don't forget to get scanned out when you leave, and then for the gala tonight, please make sure that you bring your badges because these are your gala tickets. Okay? Because we want you to get in and eat some food and have some fun. Well, those are for drinks. Those are the most important tickets, I guess, behind these. So, okay. So our final presentation is Can Smart City Solve Your Water Problems with Gareth Price? And Gareth is focused on smart city deployments. Gareth serves an integral role in collaborating with water utilities across Canada to find the solution ideal for them. Over the last 15 years, Gareth has worked in advancing smart metering solutions to help utilities transition from touch read to wireless reading systems. Utilizing his business acumen, Gareth assists clients in a consultative role to build business cases based on the client's valued proposition. As projects progress to post-deployment, he then guides clients on ensuring that the utility is maximizing their investment. Please join me in welcoming Gareth to the stage.
Well, thank you, everybody, and congratulations making it all the way through the day. It's still a full classroom. That's fantastic. Including myself, I've got Joel from Mueller also. So any questions, if you can't get hold of me, Joel will point you in the right direction and hopefully give you to somebody else, and I don't have to answer any questions. So kind of starting off with enabling smart city, and it starts off with what's smart city. And each one of you has a different answer, right, to what smart city looks like. If I went around the room and I said, what is smart city? I might get some answers like IoT, Internet of Things. But in end, it's really what smart city water can do. And really what it needs to do, it needs to provide vision. It needs to be visible, right? And it needs to be able to give you the ability to go in a direction, so actionable, visible and actionable. And that's what smart city is. I think smart city also lets you deploy, and certainly in our solution, it lets you deploy at your schedule, meaning it's not a turn the lights on type of technology that you roll out. It doesn't need to be rolled out citywide or account-wide. It can be rolled out strategically based on what your drivers are. And I go through the different slides or the different decks of solutions that we have here. It's not that you roll out one and then work through 1, 2, 3, 4, if that's what you're going. You would roll out whatever technology meets your needs. So you could roll out only technology number 2. And then I'll go through as how and what Smart City does is that then the devices can communicate with each other. So as you deploy more devices, the system does become smarter and does provide actionable data back to you. I'll show you how we get to that point. It's always weird seeing yourself on camera. I notice my hair is receding. And I think I'm getting fatter, but I'm blaming that on COVID. Okay, first off, introduction of what Mueller offers as a solution. I'll go through non-revenue water, just a point to bring up. It gives us a point of introduction into Smart City, lets us have some dialogue. I'll go through leak detection and pressure monitoring, customer usage and what we call metrology, how that can stack on top of it. And then our vision of a connected platform. And you'll hear me use the word single pane of glass, meaning that the software resides under one single software platform. So you don't have multiple softwares to look at. That actually leverages that you have one training for your staff and that it is the ability to become scalable. I stole the conference theme. I like the recycling, also the environmental being part of what the organization is. Respond, recover, and thrive. And respond and recover obviously are reactionary in nature, aren't they? The event's already occurred because you're responding and recovering. And then I added the innovate, right? If we go through that, and I think of this, my background is engineering, so I look at quality improvement, right? Isn't this a continuous improvement type of idea, right? If you can respond, recover, learn, thrive, and innovate, if you continue that cycle, you become better at each cycle, right? And that's what we're trying to show here. Mueller is a company. We've been at this for 165 years. You probably know us for hydrants. We don't have to repair ours as much as those do, but sorry, that's a terrible segue. So we've been making these devices for 165 years. We are a vertically integrated company, meaning we make it all. And what ties our platform or our product together is the software that sits over top of all this. So if we look at this schematic, really what we're about is fixing the past, helping you solve the problems of today, right? And then deploying and helping you move forward and grow, right? So it's fixing everything we've got out there, working on today's problems, but also as cities grow, helping you with that. When I did this slide deck actually a couple of days ago, I randomly picked this picture for Crossroads because I like black and white. There's some depth to it, even though it's black and white. I see a lot of gray hair, so I don't see millennials. At some point, cameras took black and white pictures, not color. There's the joke. That's how it was back then. You can see how I went into engineering and not in comedy. So we are at the crossroads of technology and innovation. And then I look at this picture again, and I thought, why did I pick it? Aren't we as a utility sometimes that person in the middle of that road? And I'm not saying you've been inactive in what you're doing. I mean, I like to offer my gratitude as a user, right? I'm a homeowner, right? And I drink that water that comes out of the tap, right? You guys are providing a 24/7 service at the highest quality, right? With no exception. That under itself, with all the rest of the hardships that you've got, probably unlimited demands on your time with limited assets, probably limited budgets, and probably you're all looking to hire 3 or 4 or 5 people. So this pressure is getting harder. But as we look at this, how do we get past these crossroads? And I think I'm going to show you how one option of looking past these crossroads. It's through understanding that there is maybe a solution for you that has all of those wrapped up, right? It could solve maybe a workforce issue, right? Can provide you vision. Remember I said if it provides vision and that vision is actionable, right? We can get a little more resourceful and performance on deploying these networks. Environmental stewardship, right? Just become better. You know, if I look at, and I'm going to pick on non-revenue water, right? If we can get better at what we're doing, right? This might push us past this crossroads of where we're looking to make sure I'm close to the microphone. And then limited resources. Not limited resources could be a bunch of things, right? Limited resources could be that in some places in the States, there's no more water to suck, right? There's no more water to deliver. So they're looking at resourcing and capping past. That limited resource might be people, right? Non-revenue water. I fucking hate that term. It got adopted about 10 years ago. As an accountant, non-revenue is cool because I'm losing revenue. It's non-revenue. As someone that we're looking at ratepayers, I'm not sure ratepayers understand what revenue, non-revenue water is. It's water loss, isn't it? If I gave you $100 to start off, Joel, and you came back and gave me 80, you've lost 20 bucks. If you had no idea where it went to, that's a little more tangible to me. And isn't that what we're doing in a water loss non-revenue calculation? And there's plenty of reasons why we're here, right? There's plenty of reasons how we get here. But that non-revenue water is one point that we'll start off on. It can be a result of incorrect meter reads. That's a small percentage. Theft, well, it depends on where you are, whether that's an issue. Hidden leaks, what would a hidden leak be? Well, a main break, something we're unaware of. We're pumping water in, but it's not getting to the final end user. Known losses, swabbing, anything else we use water for in our day-to-day operations. Maybe it's flushing a main before it goes live. Meter accuracy, aside from what the meter people will tell you, even if your meters are 20 years old, that probably accounts for 4 or 5% at a stretch, maybe closer to 3 or 4. There are some outliers, right? There's always some outliers that might be stuck on low flow, but overall mechanical meters are very accurate, even when you roll them out 20 years. Unmetered water, so this could be a bulk water station, right? You have an introduced bulk water station, so it's being used, it's not metered, and then your operational needs. All of that adds up to some number. And I'd like to have this argument when someone says they know what their non-revenue water is. Sometimes we think it's between here and there, so we'll hear numbers. Just as a sidebar, there is an account in Canada that produces 2 of these, and one of them gets, thank God I did the right one. and only one of them gets to the customer. They have a 50% non-revenue water. And when it's that bad, they're just guessing at that point. They think it's around 50%. If you happen to be from the city of Montreal, that's the city. And I guess where do they go from there? Non-revenue water, again, I say that's lost water, right? Lost revenue. The other added, and as far as, this environmental side of it, if it's a main break, we're putting chlorinated water back to your source. Becoming more and more an issue, isn't it? Operational inefficiencies. So again, I'm saying non-revenue just gets called non-revenue water, and I say it's water loss. That water loss is truly operational inefficiencies. If I've got 20% loss, I'm pumping 20% more water, right? I got 20% higher electric costs. I've got 25 or 20% more maintenance on those devices. Capital inefficiencies, I got to buy bigger pumps. I got to put bigger mains in the system just to get around that. Sidebar, main breaks in the last 6 years, kind of a lie. From 2012 to 2018, main breaks are up 27%. That's a North American study, Canada and the US included in that. So with them having more cast iron, the numbers are a little higher south of the border. On average, 10 breaks per kilometer. I find that remarkable. I almost call bullshit, but that's what the stats say. When those main breaks occur, inconvenience and confidence level back to your ratepayers. Economic impact, if it happens enough, there's some capacity issues. Water quality obviously is impacted. And I even put emergency repairs are costly. I should put the word very costly, right? The cost to do a main break when it occurs randomly, right, is extensive. On top of that, you might know if it's come to the surface, you kind of know where it's located, but the break might be further down. And I'm going to show you how we can maybe get closer to that. And the reason I put the tape measure on there, you cannot improve what you cannot measure, right? If we can measure it, we can improve on that. It's the only way we can move forward. So let's start on the leaks first. Remember these ones, I said these ones are independent of each other. This is not, you start here and move to here, you could just do leak monitoring and that's it. We could talk about metering under itself, or we could talk about pressure monitoring. You don't have to go through the deck of each one. Each deck is independent. But I'm going to show you how we can stack those and they become smarter, it becomes better overall. This is a real picture from Montreal. They decided to make a skating rink. Infrastructure in these areas, we all understand how this happens, especially in high density areas where it's either literally impossible, downtown Toronto, to rip out every piece of cast iron pipe just because everything's stacked on top of each other. And we're going to show you how we can use data and information to at least provide some longevity or extend the life of that aging infrastructure. As the leaks occur, it impacts customer satisfaction. It's obviously extremely costly to do repairs at this point, and access might be a problem. So let's do pipe leak. Anybody know what that thing on the right is? Hopefully it's the same right as my right. Yes, it is. That thing on the right looks like a hydrant, right? We see a couple of them all over, even all over the world. They might be a little different, but at the end, that's what they do. The men and women that pull up to this with a big red truck, right? That's what it's there for. Since we have this device out there, since it's connected to the main, we can put a leak detection device right on this hydrant. And the beauty is it doesn't need to be mine. I prefer it be a Mueller hydrant, or Joel does. But it doesn't need to be. It can be on anybody's hydrant. So I have a bunch of devices out there that I could use as a sentinel device. I also said earlier, you do not need to make this a system-wide deployment, right? Early on, to learn the lessons, we could do it in a geographic area. What would we look at? Typically the oldest infrastructure, maybe a downtown core, and deploy 20 of these devices to see what that information learns. I would argue we should be able to prove to you that this technology works and it helps you understand what's going on in your network. So we can put a device in strategic areas. Usually we want them on about 80% of your hydrants. That's what it looks like when it's stuck on. You see that little white strip. It's never white. It's just shown here visually so you can see where it is. It's always color-coded to the hydrant. right? 10-year battery life. It's hidden in plain sight. It also works, it also doesn't need, it leverages a cellular communication. So you don't have to deploy a network of communication devices. You're not setting up a network. It's plug and play or deploy and read, meaning if you deploy it tomorrow, you'll start seeing readings on the next day. It's because it's leveraging the cellular network. And it wouldn't be any use, right? It wouldn't be any use if that data, remember I said the data has to be viewable and actionable. If it's only viewable, but it's not actionable, it's a waste of, right? You've just wasted a resource. So I want to make that actionable. How do I make that actionable? The picture on the far right, is that actionable? It's just paralysis by analysis, isn't it? I'm just going to provide you a ton of data. I said on the right. I should have said the left. My bad. The data just comes in. That's on every node. If the data just comes in, it just becomes paralysis by analysis. So we use machine learning. So through machine learning, what we do is we say not only do we use machine learning, it also says where is the device installed? And that device starts to set a noise threshold. That noise threshold is just the acoustic leak we're normally hearing in the pipe. That's different if it's near a downtown bus stop than it is if it's in a rural area. So the system automatically adjusts and says, what's the normal background noise? And then it says, are we seeing these things condition? Are we seeing out of control points? So through machine learning, we go from left to right. I figured out which is my left now and which is my right. The one in the middle, we're noticing that we are seeing some persistent noise issues. But again, we want to make this actionable. So we end up on the right from 29,000 network noise devices all the way to 8 that we recommend are investigatable. And then from those 8, you can Pareto, right? You can determine which ones you're going to look at immediately versus secondary and tertiary. That's on acoustic leak. Any questions on acoustic leak at this point? Or anybody that's online? Cool. Either meant I put you all to sleep or I'm doing a great job. I'll let you answer that later. Pressure monitoring. Remember I said these are stacked. So it's not like you have to go through one to the other. You don't have to go through acoustic to get to pressure. You could just go to pressure. What we're trying to say is what's the problem you're trying to solve today, and let's solve that one. So it's pressure related. Let's look at solving it from a pressure point. So we can put pressure devices in your system. We put them right on the main. And what we can do is we can monitor your system pressures. What we're looking for are transient pressures. So when you hear transient, what we're saying is a spike in your pressure, right? So what spikes in your pressure are going to do, especially in the downtown core, where it's aging infrastructure, it's getting weak. If we can stop pressure spikes, or at least monitor where they are, understand where they are, and learn more, and we can reduce those pressure spikes, then what we do is effectively reduce the stress on your piping. So what we can do is monitor this in real time. Then we can learn from it and determine what course of action to take to eliminate pressure spikes. What we can also do is put pressure loggers on your PRVs. So in your PRVs, not only can we monitor your inlet, your intermediate, and your outlet pressures, we can also adjust them. So that's the next level. And what we're looking for there, a lot of it is just what's going on in your pressure. We can also look for transient detection. So that's just another way of saying we're looking for spikes. That graph is terrible because it doesn't show it. Here, I'll show you my picture. It shows a bunch of spikes going on there that are far outside of that main yellow line. You can barely see them where they're coming really high. What we're trying to do is see when those are occurring so that we can solve them, so that we can reduce the stress on your system and ultimately then create some longevity in the aging infrastructure. What we can also do, if you look at how you get to some of your system pressures, we can also look at, especially the ones that are aging, you set your system pressures and they're always the same. So you might need to get 80 PSI miles down the road or kilometers down the road. So what you'll do is during your system loading, during your high usage, you might have pressures on the inlet slightly higher. So 100 PSI on the inlet, kilometers down the way, you have 80 delivered to the final customer. That final customer complains about there's not enough pressure. What do? We just jack the pressure up a little bit if they have enough clout to complain enough. If not, we just try to make them go away. What we can do is put a remote device on there. Remember I said we can monitor and adjust your pressures with our pressure loggers on a PRV. So what we can do is say nighttime usage. What happens at nighttime? Your system pressures all go to that 100 PSI. Now, that doesn't cause a problem, but it's causing undue stress on the system, especially if it's aging, right? We're trying to solve the aging infrastructure now. So if we can put a pressure lauder on the extremities, we can then say if your system pressures at the extremities are starting to see 85, 90, 95 psi, we can reduce that on the feeding to that, reducing the pressure, reducing the spikes, adding longevity to your system. Just a picture to make it look like you all know what a PRV looks like. So that's pressure. We've done acoustic leak and pressure. Again, these are stacks. We're going to look at understanding customer usage. So on a meter side of it. And we can connect our transmitters that are going to communicate to your meters that you presently have, meaning you don't have to change out your meters. We can connect our transmitter to these meters. You don't need to deploy this system-wide. You might elect to just do your commercial industrial accounts. Why would you pick on them? Usually because it's an 80-20 rule. Your commercial applications are using 80% of your water. For me, we don't sell backflow devices, but backflows can be a little bit near and dear to my heart because my kids, my wife, my family drinks on that tap, right? And at a commercial application where they have maintenance people and pumps, there could become a problem where they inadvertently, Stratford, Ontario, had the car wash, put it the wrong way around, and people got automatic soap in their water. Didn't hurt anybody. It smelled nice. But no one knew about it until the complaint came in, right? In commercial applications, there is the where-to-all, and also in commercial applications, if we did an assessment, some of them do carry biohazardous materials, right? So they could get pumped in the wrong way. So understanding customer usage, we can get faster response. Accountants like this part. We can get faster response to meter to cycle to cash cycle, meaning if the meter's being read in real time, we can bring that right into accounting. There's not a delay in getting meter reads. We can improve customer service so your customer can get access to this data and view their data. Also, if they call in, we can let them know, we would let you know when I have a high water bill, when I've got constant usage, which is 9 times out of 9, that's an engineering joke. 9 times out of 9, it's a toilet leak, right? We can get in front of this issue now. We can call the client early. Because typically what happens is then it comes to you, ends its way on Jamie's desk. They're yelling because they never went through this water. And then usually we can look at the graph and I can see the event, water, toilet, constantly on. I can, because you tell me, the date when you sent the bill, the date they received the bill, the date they called the plumber, and then the date they called you, right? And it's always the same thing. Well, the sad part is you spend a lot of time and effort going through that cycle. And then maybe if you don't do anything or not to the customer's satisfaction, it then escalates through the mayor, and then suddenly you're asked questions. Funny enough, I was with Jamie at a mayor's meeting about one of these conversations. That's a lifetime ago. So on the data, again, it does not need to be deployed system-wide. You might only do it on your commercial accounts, or what I like to affectionately refer to as your problem children. You can put it on your problem children because you know what's going on. Likely, I love this subject because when I talk to a customer service rep, I'll say, who's your biggest pain? They know the customer's name, their address, their account number, like they know it all. The ones that always call. And this again, maybe, remember I said it has to be visible and actionable. And this is the actionable part, and visible. Meaning visibly, we're telling you on the entire system. Like this isn't just the account level, how much water you're pumping in. On the top right hand, on the left-hand side, that's the viewable, that's the graphical user interface. It's hard to see, that wasn't intentional. It's going to give you a list of backflow alarms that are going off, leak alarms that are going off, high usage alarms that are going off. It's going to give you a real-time calculation of non-revenue water, which I like to call lost water. If we get enough of these, and even if you just did the commercial, everybody's heard of DMA, district metering? So what we can do in district metering is, if we know how much water for district metering, we know how much water you've pumped into, let's say it's zone A. And you might have taken water off for zone B. I can subtract those two, that's pretty easy. And I can have how much water you pumped into zone A. If I know then how much water you've pumped to each one of the connections, I then know in real time what your non-revenue or lost water calculation is. What will that do for you as you move forward? Well, then we can have a KPI, known performance indicator. We can actually have that known to where you're sitting normally, and when that gets out of control, statistical jargon for things are going crazy. Then you know it's not system-wide. You know you can look at a zone. Then we can look at a zone and know whether it's a main break, because we might have acoustic leak. We know it's a main break, we might see pressure drops occurring, right? It just provides us with a ton of information. One of the things I did forget to mention, because we look at having an acoustic leak on the hydrants, not only does that give us a noise level, but it also gives us real time that we can actually look exactly where the leak is occurring, from which hydrant to which hydrant, where to put the shovel. So this is a district metering analytics. Now all of this, I said these are stacked, right? Each one's independent of the other. But I also said in the beginning that we want to put this all under one single pane of glass, and that's what we've done. So it sits on a vision that as you look at this vision's today, by the way, not something coming, it gives you the ability to roll out one stack, one solution, and the ability that as we move forward, you can continue to deploy that and not end up with numerous different software platforms. Because it's under one single pane of glass, those communications between the devices truly become smart city or IoT. I didn't even mention, but it also adds to it, we can tell valve position. So we can tell valve position, we can tell water quality on this same platform, and we can actually do auto flushing, other than the other plethora of other devices that can be all tucked underneath that same thing. So if you did have areas where you have residual chlorine levels that are getting low, we can monitor residual chlorine levels and have flushers automatically go off. We can meter the amount going out, put chlorine dechlorination pucks in there, and get visibility on that in real time. Choosing the right technology based on the business drivers, again, kind of the kickoff to me. I want to make sure that this solves your problem, that it's around what problem you're trying to solve at your utility. This just gives you the it is a red light, green light, just telling you that which one of the solutions and how that might meet some of your business drivers. Ultimately, these technologies help drive customer satisfaction up, give customers visibility of what's going on in their system, and actually at the end does have operational efficiencies. Our vision right here, right, as far as Mueller, we actually provide a solution all the way from the source, all the way to discharge. And that's it. I'm going to get you back to hopefully a drink. Any questions? You guys were pretty quiet. I keep moving away from the mic. That's my fault.
If you do have any questions, just put your hand up and I'll hand you the microphone just so that...
I might know the answer.
Well, yeah, maybe. No, I'm just kidding. You will. You'll know the answer, but the virtual people can't hear unless you're speaking into the mic. So any questions?
What a good group.
You answered them all.
Don't forget to tip your waiter.
So there's no and there's no questions in the Q&A online. So I'm just going to come up here. I have a little gift for you. Thank you. That was a. Thank you, Gareth. That was a great presentation. And yeah, so don't forget to get scanned out. And aloha. Well, I guess we'll see you tonight at the gala. Aloha. And again, don't forget your badges. Okay, thanks again, Gareth. It was nice to meet you.
Oh, pleasure. Well, that's your mic.